All right, so I think we're live now. Welcome everybody watching this live and watching this later to the Fedora Release Tools team demo for January. We're going to be running through a bunch of the changes that we're targeting for F24, as well as a couple of other changes that we've been working on during this time period. As always, we are in Freenode's hash Fedora-meeting. If anybody has questions that you'd like to raise, since we can't hear those audibly on the Hangout on air, so feel free to join there if you have any questions that you would like for us to see. And otherwise, we'll go ahead and get started. I will paste in a link to the agenda that we're running through to IRC as well, so that you can follow along at home. So the first thing that we have on our agenda is from Jay running through the new changes that he has for sign repos and Koji.
Thank you, Amanda. Everybody can hear me okay?
Yes, sir.
And everybody can see the screen okay? It'll just be a console.
Yes, sir.
All right. So this is what the command looks like. What I've added is the ability to specify a comps file that will be included in the repo data. So if you have group information that you want included in the signed repo, you can do so with a command like this. The skip unsigned there is just for the sake of testing. I have packages in my test instance that are signed and with different keys and unsigned, so I'm just using that to bypass it. So this will go do its thing for a little bit. I'm going to Control-C out of it just because we are on a time limit here. If I look in something that was previously generated, there is now a groups directory in the results, and that's the comps.xml that was originally passed up. That's not actually what we're looking for. What we wanted to look at is the repo data, which is going to be in the architecture and then the repo data subdirectory. And you can see right up at the top is comps.xml. That's what was originally included. And if I do the same thing, again, just so you know that I'm honest, the latest repo here is 223. If I do that here, it's done by now, and there it is. It has the same hash too. So that's that. So now you can add groups data into signed repos. Just as like a quick little note as well, this work has been deployed on Fedora's Koji stage, and work is ongoing to make that all line up. So we're getting there. But that's all I got.
Okay, give me just a second because it looks like at least one person in IRC isn't able to see the video. I guess if anybody is trying to view and can hear but is not able to see the video, chime in and I'll try to work with Randy to make sure he can see things. We'll go ahead and move on to the next item, which Adam is going to be demoing, and that is showing our dist-get and package-db changes to support containers.
Okay, so this is work actually that Pierre did for those hanging out on IRC or in Fedora land. And you probably know him as Pingu. This is around the Fedora package database as well as dist-get and the background Gitolite structure that was set up for allowing us to have different build artifacts. So let me make sure of that. Right. Okay, can everybody see a web browser?
Yes.
Okay. So this is package-db, and one of the new things that you'll note here is there's a kind of a prefix in directory structure. So there's RPM / 0ID all the way down. And then we can also look for the bulk of Docker packages, which so it will redirect, and this is yeah. That's interesting. I'll talk to Pierre about that. But if it finds a package that matches RPM, it will actually redirect. But if we look for all Docker packages that start with an R, we actually find sorry, I have the query wrong. So if you prefix the URL, if everybody can see the URL bar at the top, if you have package Docker, the namespace of Docker, and then you want to query for all Docker Git repositories that start with the capital letter R, you do R asterisk, and this will look for all of them. There's only one of them right now, so it does a direct match and redirects you to R test that. And there's also a RPMs R test that, and this is just kind of to show that we can actually duplicate naming between the two because there is a difference in structure. And then let me share. Okay, can everybody see a terminal? Okay, so this is the Gitolite structure. In the past, this wasn't broken up into different namespaces, and now it is. So we have the RPMs, which are kind of the traditional thing that Fedora's always shipped. In the future, we will have Docker containers in the Fedora 24 lifecycle. Further down the road, we don't know. We don't know what's going to be the next thing that the community decides is important, and we want to ship them in their own namespace and have a build system around them. So there's kind of this idea of foo, and that's whatever might come next. During the transition point, if anything doesn't have a specified namespace, it's going to default to the RPM one. So if I were to do like fed package, I don't know, it's just going to pull Ruby, and you'll note there's warning. Ruby is an alias for RPM's Ruby, and it'll pull that down. Whereas if I were to do fed package clone, fed package clone RPM / Python, that warning, but it's going to go ahead and pull down the fed package Git repository for the Python RPM. And there is also, I don't have access to it, but there's also an administrative UI update for the package database, so that if you are creating a new build artifact entry into the package database, you can select between the different namespaces to make the entry in the appropriate place, and that will facilitate our ability to have different build types as we move forward. So when you do like a fed package build in the context of a repository, there will be the notion of different types of artifacts. So that's it in a nutshell.
All right, then next up on the hit parade, we have Lubos running us through, hopefully this time, a successful demo of some of the changes we're getting in place for Punji, since last time we failed to do that.
Yeah, well, let's try. Can you see my screen?
Yep.
Yes, sir.
Great. So I'm going to actually show you what the compose looks like instead of just showing what it looks like when you run Punji, because that's not particularly exciting. So as you can see on the screen, the compose actually creates quite a lot of stuff. The most important parts are in the compose subdirectory, where the interesting part is the metadata section, where everything about the compose is actually stored. These files are in JSON format that is actually documented, so it can be used for any consumer. It tells you for what variant and architecture where different stuff is. And also in the RPM sections, for example, it lists every single RPM that's in the particular compose and with what key it was signed. Obviously, okay, my browser just froze because this file is really, really big. There's a file that looks pretty much like this for images that lists all ISOs and Docker images and whatever may be built in the Compose. Okay, this is, oh great, it's live again. So, for example, for the server, let's look at the packages. As you can see, they are broken down by the hashing of the names, so that the list is reasonably long. And that's pretty much it for the stuff that is composed. The second part of the structure here that you can see is work, which is not very useful for consumers, and it's actually not that useful for people running Pungi either. It's basically a temporary place. What might be useful is the log subdirectory, which, by the way, contains a dump of the configuration that was used to create this compose, so you can actually see what was actually done. Now, I'm going to show you some parts of this configuration that were implemented recently as enhancements for F24. Now, the one part is that currently Pungi can mark certain stuff as possible failure without actually failing the whole compose. Originally, when anything failed, we just marked the compose as failed and nothing else happened. With this change, it's actually possible to say, for example, we don't really care about images on i3 or on a particular architecture that much. If it fails, just put it in the log and continue and go on. And technically, this is currently being used because some of the images fail to build, but the compose still successfully finishes. And it contains a log that says, hey, I failed to create these 2 images, but the rest is there. And while I'm talking about the images, that's actually the part that was modified the most. Pungi does not build the images itself, it calls out to Koji. So this is the configuration that says that for the cloud variant, build images for this architecture with these parameters, like say in the Docker format. There's actually a typo here. The disk size should probably only have 1 I, but that's not a big deal. So Pungi takes this configuration, calls out to Koji, and waits for Koji to actually build all the stuff, then downloads it and puts it in the proper place. And this is actually what it does for most of the deliverables, not just images, but also for ISOs and live images in the future. So that's actually the quick overview. And that's all I have for today, most of the changes.
Okay, great. Thank you for running through those. So then the next thing that we will demo, and this will be the first time that we're showing anything in this space, I'm pretty sure, is work that's been going on around moving to using Live Media Creator for creating live CDs. And Dennis is going to run through that for us.
Okay, let me share my desktop. And just share the entire screen. Can you see everything okay?
Yes, we can.
Okay, let me find the right tab here. Okay, so the Spins kickstarts to switch from Appliance Creator to Live CD Creator. We need to add a couple of extra config options here for Anaconda. We need to tell it to 0 the MBR and clear all the partitions. Need to bring up the network and tell Anaconda to shut down at the end of the install. We also need to include a couple of extra packages. Kernel modules extra have to be included. If they're not explicitly included, Anaconda, for whatever reason, decides it's going to install the debug kernel, which makes the image bigger and makes things slower and is not what we actually want to ship. We need to pull in a couple of extra things. The direct config generic, we want to disable the config rescue because it's kind of pointless having the rescue option on a live CD. We need to include syslinux, and we need to include grub2-efi. The grub2 package is a x86-64 only thing. So to work around that, I've created a new comps group called, where did I put that? There's a new comps group called Live CD Tools, which includes all the extra packages that we need to bring in, including the Druckout Live. So I'll switch the kickstarts to just include the Live CD Tools group, and it will pull all of these packages in to the install, and that way the live CDs on i386 will not fail because they can't find grub2 EFI, because DNF is a little stricter than what live CD tools was in regards to that. So now you can see one of the Koji tasks. We still have some cleanup to do on the Koji web interface to make it a little neater and more user presentable, but it's in the live media channel. We have a parent task that's live CD for Fedora Workstation 24, passing kickstart. So on the x86-64 task it's going, we have the kickstart that was fed in, we have the kickstart that Koji has modified to include the correct repositories and to add the URL line, and then we have the standard mock output files. And I have one we did earlier, which is the scratch build that completed. So in the end, the output that we get is a live CD ISO, as well as the input and output kickstart files, all the Anaconda logs, which includes anaconda.log, DNF logs, Hawkeye log, the log files from the snippets in the kickstart, all the output from Live Media Creator, a manifest log, which is just shows what's in the contents of the ISO, all the output from mock, the packaging log, and Anaconda logs. So by capturing all of the Anaconda logs, I'll stop sharing now. By capturing all of the Anaconda logs, we have everything that we need logged in order to be able to, figure out why any fail happens. If for some reason Anaconda goes a bit wonky, it will give us all of that input or that output, so we can analyze and get fixes done in Anaconda. We had to scale so we run Live Media Creator, which executes Anaconda, and we're running it all in a chroot. And as a result of that, only the live CD function of Live Media Creator worked. All the other functions require vert to work, which is a bit difficult to run inside of a chroot. So going forward in F25, we're going to work on ways to extend the functionality so that we're able to deliver all the different types of artifacts. But for now, we can have live CDs using Live Media Creator in F25. And if there's any questions on anything or logs or something you want me to show, let me know.
Just one observation. I noticed the ISO doesn't have the architecture included in there. You might want to have that in the file name.
It's supposed to be in the file name. I think that's probably a bug in Koji, because it's supposed to pass that in.
Okay. I just wanted to highlight it because when you create them for multiple architectures, you're going to run into collisions when you're saving in the database.
Correct. So at the moment, the one thing that's missing is the function for Live CD Creator that got the RPM manifest and kept a record of all the RPMs that are installed into the ISO doesn't work. So we're limited to doing scratch builds right now until we fix that up. So we can't actually import anything. But yeah, that's
got it. Yep. So it's still a work in progress. Got it.
Yeah,
that's fine.
So yeah, still a work in progress, but it's getting there. We're actually, today's the first day we've been able to send a task and actually get the i386 and x86 64 tasks, children tasks from the same parent. So, making fairly good progress.
Okay. All right. So certainly if and as folks have questions, feel free to pepper those into IRC, but we'll move into the last thing that we're demoing here, which is Kushal showing us automation of testing our AMIs in EC2.
Okay, so can you see my screen?
Yep.
Okay, so that's the URL for the Tunir project, and the demo I'm going to do right now, the code actually resides in the master branch there. So if you want to play with it, you can just do a git pull, git clone, and try it out yourself with your access details. So as you know, the Tunir jobs are basically one JSON file and one text file. So this is an example of a AWS-based job where we are calling the type as AWS. The image is the AMI details, and you know the username, the RAM is right now I guess we're not using this, but it's just there because I copied it from another config. These are a few important things. The key, the SSH key, it's going to use to access the instance, then your access key and the secret key so that it can actually talk to AWS. The key name it's going to use to, while creating the instance, and obviously we want a security group so that we can SSH into the instance, and web type can be either HVM or paravirtual. So if I see just another example, this is word type is HVM, and if you start a job like this, this is an example job which I just ran a few minutes back. So it will start a job and then it will follow the same procedure what it does for Vagrant or cloud images. So basically it will take some commands. In this case I was just doing cat up etcos release, and we'll get the output and it will tell us the status, and finally it destroys the EC2 node. So one major thing about this particular feature is about the cloud itself. Because we are doing everything on a EC2 node, we are not very sure that whether that creation of that node will be successful or not. So this job actually retries few steps again and again to see whether the IP came on right time or not, or the instance is up and running or not. So it tries to recheck various things. That means the the job run takes a little bit more time than the standard within a minute of normal, say, cloud image job. So that's the only extra thing it has, like few for loop times max, and then it goes ahead following the same rules using Paramico and logging into it with SSH and executing the commands. So that way the output is exactly same for any other type jobs like cloud or background. That was the main part. If you have any question, and this is actually it works and it's there in the GitHub. So if anyone wants to try it out, you will require your own AWS access keys, like the secret key and the access key, I guess.
Okay, and as far as plans going forward, Kushal, this testing will be rolled up under what we report in AutoCloud?
Yes, so there is another work going on right now to rewrite the parts of Fed image, our tool or service which creates these AMIs. So after that, we'll not, right now it basically turns on that AMI and tries to run /bin true command. So instead of that, we'll be running the exact same test cases which we run for the cloud, normal cloud or atomic image, but on EC2. So when we deploy the new Fed image, along with that, we'll enable these testings on AutoCloud. So that will ensure that we run the exact same test cases, whatever is the platform, like normal cloud or Amazon or Vagrant or any future cloud providers if we support.
Okay, it just gives us better automated testing as part of our atomic releases. So
Correct.
that's great. Okay. I will give a forum if there's anything that anyone who's demoing thinks they missed or wanted to mention before we drop. Speak now or forever hold your peace time. It doesn't look like we have any questions in IRC to cover. So if we have nothing from either side, then we can go ahead and wrap up. And I will thank everybody for demoing and everybody for watching. As always, you know where to find the group, mostly in Fedora Relinge on Freenode. So if you have any questions later, you can bring them there. And of course, we'll be demoing again in February when we hope to have most of these changes for F24 wrapped up. So we'll see everybody again in a month. Thank you for joining.
Thank you.
Thanks.